Oh, it's not working.
Okay, so, are we good, Imogen? Have you got that video?
Yeah, it wouldn't work if I put the glasses on it though.
No. Okay, so what we have got in terms of types of waves, Luke, can you sort it out, please? Thank you. What we've got in terms of types of waves is two main sorts, transverse and longitudinal. And the difference between them is the direction that the medium, the thing the wave is travelling through, is being displaced. So we can think about both of these two waves that we've got drawn on the board here as moving in a direction. And so in the case of the transverse wave, what we can see is that although the wave is moving to the right, the medium, the thing it's travelling through, is being displaced up and down at right angles to the direction of travel. So that's the key thing we need to know about a transverse wave, is that the medium is displaced, it's moved, at right angles to the direction of travel. So for instance, like that, we've got it being displaced up and being displaced down. And a little bit of naming, when it's displaced up, we call it a crest, and when it's displaced down, we call it a trough. And so then moving on to the longitudinal wave, it's like a compression wave. And so in the case of the longitudinal wave, to form these areas where the wave fronts have been compressed together, we can see that we must... Okay, so longitudinal waves. Longitudinal waves are similar to transverse waves in that the medium, the thing they're travelling through, is displaced as the wave travels through it, but unlike a transverse wave that has the medium being displaced at right angles, up and down or side to side to the medium as the wave travels along, in a longitudinal wave, the medium is travelling forwards and backwards as the wave travels along. There's areas of compression where the medium is squeezed together, and areas of rarefaction where the medium is spread apart. And so the particles in our medium are being displaced parallel to the direction of wave travel. That's the key thing that is the defining difference between a longitudinal wave and a transverse wave. And so transverse waves, we're thinking about things like sound waves, where as we're talking, it's causing the particles in the air to be compressed together and spread apart, and then that area of compression and rarefaction travels through the air and hits our eardrums and makes our eardrum move in and out, and that is interpreted by our brain as sound. We understand what people are saying. Hopefully. Moved them sort of in. And the last thing that we should add on to this is examples of this type of wave. So transverse waves, electromagnetic, e.g. light. Electromagnetic is like the word that is all-encompassing for light, ultraviolet light, infrared, X-rays, radio waves, microwaves, gamma rays. All of those things are types of electromagnetic radiation. Also water waves and seismic waves, like the earthquake waves that are travelling around the surface of the planet.